All right, so today we're going to look at 1.5. Now your 1.5 homework packet, that'll be included in this email where you have the video link. So look in your email, same place you got the video link. Also, it'll be in Blackboard. And your new homework packet is 1.5 through 1.8. Since we missed class this week, I'm going to make the video a little bit shorter. We're only going to be covering 1.5. So we're now going to look at some questions from our textbook out of 1.5. And these are applications. And these applications are going to require you to use the quadratic formula or factor. And we also have to remember when we solve these type of questions, you might get two solutions and one of them may not work. For example, a negative time or a negative length or width. That would not work. So you would throw that one solution out. So we're now going to begin with question number 16. And this is going to be on page 147. And these are consecutive integer problems. So let's first remember how to set these up. So this is going to be on page 147 of your textbook. And we're going to now be looking at question 16. These are consecutive integer problems. Now, how do consecutive integers work? Well, consecutive integers, remember, are back-to-back numbers. So just plain consecutive integers have a gap of 1. So if we work with just regular consecutive integers, the gap is 1. So our first number is always going to be called x. Our second number is x plus 1. And our third number, if we need it, would be x plus 2. Now, if they are even or odd consecutive integers, the gap is going to be 2. So we'll have adding 2 every time. Instead of just 1, we'll be adding 2. So even or odd consecutive integers. These have a gap of 2. So my first number is x. My second number is not x plus 1. It's x plus 2. And my third number would be x, adding 2 to that, plus 4. So this is how we're going to set these up. It's either consecutive or consecutive, even or odd. Only difference between them is the gap. So we're now going to go to page 147 of our textbook, and we're going to look now at question 16. So question 16 says, the sum of the squares of two consecutive even integers is 52. So we know we have even integers, so that means our gap is 2, and we have 2 of them. So these are even. So we're going to have a gap of 2. So the first number, we're going to call that x. Our second number is going to be x plus 2. Now, what are we looking at? We are looking at the sum of the squares. So the sum of the squares would be the first number squared plus the second number squared. That's your sum of your squares. And what does it equal? It says in this case, it equals 52. Now we can fill it in. All right, so what do we know? We know our first number is x, so that's going to come down as an x squared. Be careful with our second one. What's our second one? X plus 2 quantity squared. And that equals then 52. So how do we handle this question? Well, for this question, we're going to have to FOIL, set it to 0, and factor. So let's go ahead and take out our x plus 2 quantity squared and FOIL it out. So we've got x plus 2. X plus 2, we FOIL, and that gives you x squared plus 2x plus 2x plus 4. And that condenses then into x squared plus 4x plus 4. So rewriting, we now have x squared plus x squared plus 4x plus 4 equals that 52. So we've got our equation set up. Now we need to set this to 0 and factor it. So the x squareds can go together. So that makes it a 2x squared. I'm going to move that 52 over. So we'll add that 50, or subtract that 52 from each side. So now we're left with 2x squared. And we've got a 4x. And then we've got, looks like a minus 48, I believe here. Because 52 minus 4, that's your 48. And that equals 0. Now, we could factor it the way that it is, but that would require factor by grouping. What do we notice? Well, we should be able to notice that all of the numbers in front, all these coefficients, are divisible by 2. So let's go ahead and take our equation and let's divide everything by 2. That's just going to make it a little bit easier. So everything is divisible by 2, and then we won't have to factor by grouping. So that gives me then x squared. 4 divided by 2 is a 2x. A 48 divided by 2 is a 24. And that then equals 0. Now we can quickly and easily factor this down. No number in front, so we'll put the 1 here. 1 times a minus 24 is a minus 24. And so we know we need one number positive, one number negative. Remember, since this is negative, that means one positive, one negative. Sign in the middle is positive, so larger number is positive. Smaller number is negative. So how about we use 6 and 4? So we need a positive 6 and we need a negative 4. Jumping to my factors, I then have x plus 6, x minus 4 equals 0. Solve each piece, and so we have x plus 6 equals 0. Moving it over, we get x equals a negative 6. X minus 4 equals 0. That gives us x equals 4. So those are our two numbers. Now, when we answer our question here, we want to make sure that we get two pairs of numbers, because you're going to get a positive set and you're going to get a negative set. So my first number is 4, so adding 2 to that would give me a 6. So we've got 4 and 6. That's one set. What's our other set? Well, if we have a minus 6 and we add 2 to that, what do we get? Minus 4. So these would be your two solutions. Each one of these has two numbers, so there's two sets of numbers here. How could you check it? Well, we can check it by squaring. 4 squared is 16. 6 squared is 36. And if I add them up, what do I get? 52, which is what we should have. Okay? So that is how you work through a consecutive integer problem. And there's a couple of these in your homework to look at as well. Now we're going to move on and we're going to look at some others. So we're now going to move on and look at question 27. So question 27 is next here. So I'll put this up on the screen so we can see what we're looking at. We're going to be looking at question 27. And all of these questions are a little bit different. we're going to look at question 27. We'll do 27, and then we'll come back and do 25 as well. So this is on, again, page 148. We're going to do 27, and then we'll come back and do 25. So this is working with the volume of a box. So a rectangular piece of metal is 10 inches longer than it is wide. Sides with 2 inches are cut from the four corners, and the flaps are folded upward to make an open box. The volume of that open box is 832 cubic inches. What were the dimensions of the original piece of metal? So let's first begin with our sheet of metal. So what do we have? We have a piece of metal that is 10 inches longer than it is wide. So let's draw our metal piece here. 10 inches longer than it is wide. We don't know how wide it is, so we'll call that x. The length is 10 more, so that's x plus 10. Now, what are we planning on doing here? Well, we need to cut this and we need to make a box. So we're going to make a box, and it's going to look like this Kleenex box here. I have to fold the sides up. Okay, this originally was a flat piece of cardboard. You could fold the pieces up to make a box, and that's what we're looking for, is a box like this tissue box. So we're going to begin by taking out the corners. So we're going to begin by taking out 2 inches from each corner, and then we'll redraw our figure. So let's try and redraw our figure here, redimension it. Okay, so this is what our figure is going to look like after we take those 2 inches out. Okay, so we try and make this look right here. Sorry about it not being the greatest picture, but you get the idea. Okay, so we took our pieces out, and that's what we have. So we have this. We have sheet of metal. We cut out those corners. So what do we know about the length down here? Well, the length was originally plus 10. We're going to take 2 inches out of each side. So that means we're going to take out a total of 4. So instead of it being plus 10, it's now only going to be plus 6. What about this little edge here? Well, this little edge was x. Now we've got to take 2 inches out of each one, so it's going to be x minus 4. And now we're going to fold this up, and we're going to try to draw our new figure. So this is going to fold up and make a box. So let's try and fold this box up, and then we'll dimension it. And then we'll use our volume formula. So this is what we've got. We've got our rectangular solid here. Okay, so this edge here goes with this. So this is going to be x minus 4. This edge goes with this one. That's x plus 6. And what about the height? Well, how much did we take out? We took out 2 inches. So that height is now 2. When we go to the back cover of our textbook, we're looking for the rectangular solid. And the rectangular solid has a volume of the length times the width times the height. So your volume is length times width times the height. And when we read that question from our textbook, it's going to give us the height here. And that height was given, or that volume was given to be in cubic inches. Let me find it real quick here. Okay, that volume in cubic inches was given to be 832. So the volume is 832. So what do we know about our pieces? So our length, that's going to be x plus 6. Our width, That's x minus 4. Our height, h, is 2. And so then our volume, v, would be 2 times x plus 6 times x minus 4. And that is still going to equal now your 832. How would we solve this? Well, again, this is going to require us to FOIL. Before we FOIL, though, that 2 has been factored out, and both sides are divisible by 2. So let's go ahead and divide both sides by 2 since it's been factored out. And that's going to save us a step here. So 832, divide that by 2, that's 416. So 416 equals x plus 6, x minus 4. So we're now going to FOIL over here. These questions are difficult because they're difficult on the setup and they're also difficult on the solving. So let's now go ahead and FOIL this out. We've got x plus 6, x minus 4. So we're going to FOIL. And that is then x squared. Okay, so first times first. Outside and outside is a minus 4x, a positive 6x, and then a minus 24. Combining, we now have x squared plus 2x minus 24. So we have now FOILed it all out. We're going to solve this by setting it to 0. These should all factor unless they specifically say use the quadratic formula. Or round. If they say round or use the quadratic formula, then you're going to have to use decimals. Otherwise, they'll factor. Okay, so this one's going to factor out nicely. We're going to move that 416 over with subtraction again. Rewriting it gives you x squared plus 2x minus, I believe, 440. Yep, minus 440. And that equals then 0. So we got a minus 440 in the box. What do we know? We know one of them is positive, one of them is negative. Sign in the middle is positive. So the larger number is positive, smaller one is negative. So 440, we need a difference of 2. So how about we use a, we can start with 10. 10 and 44 does not work. How about we try a 20? It's just a matter of trial and error. 20 and 22. So we've got a 22, and we've got a minus 20 here. That then factors into x plus 22, x minus 20. So x plus 22 equals 0. That gives me x equals a negative 22. Now, can we have a negative length or width? No. So that means that this one will not work. So the negative 22 is going to be canceled out. What about the other one? X minus 20 equals 0. That gives me x equals 20. And that seems like it could be a legitimate answer. Now, we do want, in this case, we do want dimensions of the original figure. So the original figure is getting redrawn over here. So the original sheet of metal. Original sheet of metal was x by x plus 10. So this piece right here is x, so that's 20 inches here. And there is that solution. The one on the top is x plus 10, so that's 20 plus 10, which is then 30 inches. So the dimensions of that sheet of metal are 20 by 30. That was question 27. We've got a few more to look at. Let's go back and look at 25. Okay, so we'll go back now and look at 25. These questions take a while to go through, so don't think you can just work these out in 5 minutes. They take a while to set up and understand what's happening. So we're now going to move on and look at question 25. And we can go over some of these next class period as well if we need to. So we're going to go back and look at 25. It's a little bit different. It's another type of geometric figure problem. So question 25. Let's see what we've got here. We're trying to center this rug in this room. So we've got a rug that is 12 feet by 15 feet. I'm sorry, the room is 12 feet by 50 feet. We don't know the rug, but he wants to have a uniform strip of rug flooring around the room, around the rug. He can afford to buy 108 square feet of carpeting. What dimensions should the rug have? So we're going to try and get this rug to fit in the center of the room and make sure that we have a border all the way around that room. So let's start by dimensioning our room. Our room is 15 by 12. So we've got 15 by 12 here, and then we're going to put a rug in the middle of this room. And there, of course, is going to be a gap on that flooring, but we want to make sure that that gap is the same all the way around. So we're going to put an X here for that gap. So that gap is X on all the sides. So it's X all over here. So that's what we've got. Now let's try and figure out what the dimensions of that rug are going to be. Well, if I try to take that rug out on its own, so this is going to be the rug. So we're going to take the rug out. That rug has to fit in this room. This room is 15 feet long. Now there's some missing because of the border. So we know it's 15 feet, and then we'll have to take off an X and another X because there's two sides here that have to come out, two pieces of border. So the length of that rug is going to be 15 minus 2X. Now what about the width of this rug? Well, it's 12 feet for that room. How much is gone? X and X. So that's 12 minus 2X. Now we can finish this and build our equation. So what do we know? We know that we can have 108 square feet of carpeting. So that means the area of the rug is going to be 108. And the area, again, is length times the width. So what does that look like then? Well, that looks like 12 minus 2X times 15 minus 2X, and that's going to equal our 108. So that's our equation. So we now have our equation. Okay, so let's go ahead now and finish this out. We're going to have to FOIL. So we'll go ahead and FOIL it out. So you write it out one more time and we'll FOIL. 12 minus 2X, 15 minus 2X equals that 108. We're going to have to FOIL. And we're going to have to FOIL out 12 minus 2X and a 15 minus 2X. So we'll go ahead and FOIL this out quickly here. 12 times 15, that's 180. Minus 24X, minus 30X. Watch your signs, negative and negative. makes it a positive 4x squared. So that's what we have. Now we can use this, set it to 0, and solve it. I'm going to write it in the correct order. We'll write that 4x squared first because it's the highest power. These can go together. Those can go together, and that's going to make that a minus 54x here. So we've got a minus 54x here. And we've got 180, and that equals 108. We're going to move that 108 over with subtraction. And now we have 4x squared minus 54x. And then we've got 180 minus 108. That makes it a 72. And that equals 0. Now let's see what we can do. What do we notice here? We've got a 4, a 54, and a 72. Well, these are all divisible by 2. So let's divide everything by 2 to make my numbers smaller and easier to work with. So divide everything by a 2. So that then leaves you with now 2x squared. We've got 54 divided by 2. That's a minus 27x. We've got 72 divided by 2. That's a positive 36, and that equals 0. We are going to have to factor by grouping. There's no choice in that, so we are going to have to factor by grouping. So first times the last. 2 times 36, well, that makes that then a 72. And what do we know about that 72? Well, 72 is positive. So that means either both numbers are positive, both numbers are negative. Sign in the middle is negative. It's an even number, so let's start with a 4. Okay, let's try a 4. 4 and 18. Well, 18 and 4 is 22. So that's going to be too big. So let's try a 3. How about 3 and 24? Well, 3 and 24 gives you 27. So we need a 24 and we need a 3. These are going to be negative because the sign in the middle is negative. Unfortunately, we're going to have to factor by grouping because of the 2 in front. So now I have 2x squared minus 24x minus 3x plus 36 equals 0. First two pieces, I can factor out a 2 and an x, and that leaves you with an x minus 12. Next two pieces, it begins with a negative. So I'm going to factor out a negative 3. And that leaves you with an x minus 12 as well. These two are the same. So that's going to come out as an x minus 12 and a 2x minus 3. Now we can solve it. So we've got x minus 12 equals 0. Moving it over, x equals 12. Our other solution is 2x minus 3 equals 0. So 2x equals 3. Divide by your 2. So x now equals 3/2. Only one of these solutions is going to make sense. The one that will not work is the 12. Why not? Because this is a border around this rug. That 12 is not going to fit in that room. That room is 12 by 15. So the 12 wouldn't even fit in there. That would mean there's no rug left at all. So that's not going to work. So what does work for us is this 3/2. So what's our answer then? Our answer is 3/2 feet or 1.5 feet. Okay, either one would work. Or the decimal. So either one of these will work. Or you could use the decimal as well. So it's going to basically be 1.5 feet all the way around. And that's going to allow me to have the maximum amount of carpet for this rug. It doesn't ask specifically, well, let's make sure we answer the question. Okay, so this is the dimensions of the gap. So what's my rug going to be? Okay, so this is not our complete answer. We have to go back and read it again. You got to always go back and double check it. This is the gap. Okay, so this is the gap around the room. Now, what does our rug look like? Well, our rug looked like this. Our rug was 15 minus 2x and 12 minus 2x. So this is going to be our rug. We can fill it in. So that's 12 minus 2 times 3 halves. So that's 12 minus 3. So that makes that piece a 9. What about down below? Well, that's 15 minus 2 times 3 halves, which is then 15 minus 12, which is then, or not 12, those cancel, sorry, 15 minus 3, which is then at 12. Sorry about that. So that's my 3 there. So that makes it 12. So the dimensions of that rug, here's our actual answer. Dimensions of that rug are going to be 12 feet by 9 feet. Always make sure you go back and answer the question. So our rug is 12 by 9. Okay, so there's that rug dimension. We're going to work out a couple more of these. The notes will be posted along with this, so you'll be able to keep track of the notes with the lecture. Okay, so that was question 25. We've got 3 more of them I'd like for us to look at today. So let's look now next at question 32. So question 32 is next here. Okay. So question 32 from our textbook. This one's actually a little bit easier. And this one's just talking about a rectangle. So a rectangle has an area that is numerically twice its perimeter. If the length is twice the width, what are the dimensions of this rectangle? And so this is question 32 on page 149. So let's draw our rectangle up. We'll label it. And then we'll solve this question out. Okay, so this is page 149, question 32. We've got a rectangle. And here's our rectangle. And it says a rectangle has an area that is numerically twice its perimeter. So the area is going to equal 2 times the perimeter. So that's going to be written up here. Now, what do we know about this rectangle? Well, by reading it, we know that its length is twice its width. So I'm going to call the width x here, and the length is twice, so it's going to be 2x. So let's find the area of this rectangle. Well, the area of this rectangle would be the length times the width, and that would be 2x times x, which is then 2x squared. So there is one of them. That's the area. We're going to fill that in to build our equation. So that's 2x squared there. What about our perimeter? What's the perimeter? Perimeter is sum of all the sides, remember? So the perimeter is sum of all the sides. And that would then be, starting going around, x plus 2x plus x plus another 2x. Adding those together, we get 6x. So we'll put that 6x in for our perimeter over here. So there's our perimeter. So multiplying, that gives me a 12x. equals 2x squared. What do we notice about both sides? Both sides have a 2 in them. So let's go ahead and divide out that 2. And that leaves you then with x squared equals now 6x. Never ever divide by the variable x. It's not correct to do that. You'll lose a solution. So move that 6x over. And now we've got x squared minus 6x equals 0. Factor out that x, so that's going to leave you with an x minus 6 on the inside here. And what do we know about our two solutions? Well, one solution is easy. One solution is x equals 0. Our other one is x minus 6 equals 0. So x then equals 6. Now, which one does not make sense? Well, do we want a rectangle that has no length or width? No, that obviously does not work. So the 0 is gone. Now we do want the dimensions of this original rectangle. So let's redraw our rectangle and fill it in. The original rectangle was x by 2x. So that's going to make this then 6. And 2 times that 6 makes it 12. So it's a 6 by 12. We don't have any units to put on here. So we'll just leave it as 6 by 12. So that's how we work out question 32. Okay, let's move on and do a few more. We've got 2 more to look at. We're going to look at 36 and 37. So we'll look at 36 next. And this one involves the Pythagorean theorem. And the Pythagorean theorem works when we have a right triangle. And the Pythagorean theorem says that we can square the two short sides and they'll equal the long side squared, the hypotenuse, the diagonal. So we've got our figure right here. We're going to draw out this figure. And then we'll get our equation from the Pythagorean theorem. So what we've got is we've got this. We've got our right triangle. And this is 50. X plus 10 here. And x along the bottom. And the Pythagorean theorem says this. So the Pythagorean theorem says a squared plus b squared equals c squared. And that comes from this triangle. Now, it doesn't matter which one is the a and the b. The important part, though, is to make sure that the c is the diagonal. So this is going to be your c here. This will be your a or b, doesn't matter. We'll just call this one a, this one b. And we'll plug them into our formula, and we'll solve it. All right, so let's see what we've got with our Pythagorean theorem. We've got a squared, so that's x squared, plus x plus 10, quantity squared, equals now 50 squared. We're going to have to FOIL that x plus 10 over to the side here. So x plus 10 times x plus 10 is x squared plus 10x plus 10x plus 100, which is then x squared plus 20x plus 100. And on the right-hand side, don't forget to square that 50. And 50 squared should, I believe, be a 2,500. Yep, and it is a 2500 here. Okay, so there's your 2500. Now we can solve our equation. Okay, so we're going to have to set this to 0. So I'm going to move that 2500 over. That leaves you then with, when we rewrite it, 2x squared plus 20x minus 2400 equals 0. Always double check to make sure you can't divide out by a number or factor it out. And it looks like we can, because we can go ahead now and divide everything by a 2. It's all divisible by 2. So we'll divide everything by a 2 here. And that leaves us with something a little bit easier to factor. So now we've got x squared plus 10x minus 1200 equals 0. How do we factor something that's got this large of a number? We multiply, we get a minus 1200. It's minus, so we know one's positive, one is negative. And let's talk about that 1200. It ends in a double 0. What two numbers are going to multiply together to give you 12, subtract from each other to give you 1? Well, that's 4 and 3. Okay, we add in those extra zeros, that makes this 10, and this have the double zeros here. So how about we use, a positive number is larger here, my mistake. How about we use a 40 and a negative 30, because we can split up those zeros, right? We can split them out. So now we have x plus 40, x minus 30 equals 0. So x plus 40 equals 0. So x then equals a negative 40. X minus 30 equals 0. So x equals 30. Now, obviously, the x equals a negative 40 is not going to work because x is a length here. So that has to be thrown out. Now, what we need to find is both the vertical and the horizontal distance from the ground. So let's quickly draw our diagram up here. And we've got this person holding a kite on a string. We need to find the distance from the ground, both vertically and horizontally. Well, it says it's 5 feet off the ground, so this person's holding it 5 feet in the air. So we know that. Now, this is going to be x plus 10, so that's 30 plus 10, which is then 40, and that makes that total vertical distance here 45, right? Because you have to add that 5 on. So the vertical is going to be then 45 feet. So that takes care of that piece. Now, what about the horizontal? Well, the horizontal was simply x. We don't have to add anything to it. So my horizontal will simply be 30 feet. So 45 feet vertically, 30 feet horizontally. One more to look at, and we're going to look at 37. So this is going to be our last question, and I am going to change it a bit. I'm going to change it so that question 37 will go with your homework question number, let's see, which one is it? It's, let's see, because we're looking at 37. It's going to look like question 2 for your homework. And these are labeled in your homework as to which ones match with what. So question number 2 is going to look like this from your homework. We're going to look at 37 though. So this is 37 on page 150. So we've got a lawn, and we want to make sure we water the lawn. Now, the way it's set up here, it's not set up the way you would want to do it. Because if you're trying to water this lawn, you don't want any dead spots. All right, so you would actually have it go outside. So we're going to redraw this diagram so that it makes sense and so that it matches up with question number 2 in your homework. But we're going to keep everything else the same. So a square lawn has an area of 800 square feet. A sprinkler is placed at the center of the lawn, and it sprays it in a circular pattern. We want to find the radius of this circle. So we're going to redraw this a little bit differently. So we still got our same square. And it's x by x again. But we're going to place a sprinkler here. And we're going to work our way around the circle. So let me get a better color. So here's our radius. It's going to be right from here to here. And then the water's going to go out in the outer edge. And this is like what you would see at a restaurant. They're going to water part of the street because they want to make sure all the grass gets wet. Otherwise, you have dead spots. So you wouldn't want to do that. So you would want it to look like this. So let's begin by looking at the square itself. Well, we know a square has the same length and width. So this is x by x. And we know that area of this square is x by x, so that makes it x squared. And we also know from the question that this area is 800, because it says that area is 800 square feet. How would we solve for the x? Well, we would take our square root, and don't forget your plus or minus, and then we'll break up that root as much as we can. So that gives you then x equals now plus or minus 800. We can break that down because we can break that 800 down a couple of different ways. But how about we use a 2 and a 400, because 400 is a perfect square of 20. So that means then that the 20s are going to come out. And then we have a square root of 2 left over. We don't need the plus or minus. What we've got now is we have x equals the 20 square root of 2. We don't need the plus or minus because, again, this is a figure. And that's not part of it. Can have a negative answer. So now we're going to rewrite this again. And now we know it is 20 square root of 2 by 20 square root of 2. We need to find from the center this radius. Well, what can we do? Well, we can make triangles because we can solve a triangle. So I can split this up into quarters just like this. And this shaded piece right here, I'm going to take this shaded piece out. So I'm going to take that shaded piece out, and we're going to examine that shaded piece right here. Now the radius, you can use an R or an X, it doesn't matter. But what about the length and the width? Well, they should be the same because they came from this square. Okay, this entire part was 20 square root of 2. So that means this is this one is 10 square root of 2, and this is also 10 square root of 2 because it gets halved. Now we can apply our Pythagorean theorem and finish out this question. So let's go ahead now and apply our Pythagorean theorem. What do we know about our triangle? Well, if we redraw it up, this is your x, so this is going to be now your c. 10 square root of 2, that's going to be your b. And 10 square root of 2 down here, well, that's your a. And we know from our Pythagorean theorem that a squared plus b squared equals c squared. So then we know we have 10 square root of 2, quantity squared, plus 10 square root of 2, quantity squared, and that's going to equal x squared. Now, how do we handle all this squaring? Well, when we square, we have to remember to distribute the square through. Okay, so 10 squared is 100. So that's going to come down as 100. And square root of 2 squared is a 2. Same thing in the next part, 100 times that 2. And that equals then our x squared. So that's 200, another 200. That leaves me then with x squared equals 400. We're now going to take our square root, plus or minus. And what's the square root of 400? Well, the square root of 400 simply comes out to be 20. So that gives you an answer then of x equaling now 20. And so your radius would be 20 feet. It's a little bit different than how it's set up in your textbook, but this is how question number 2 is solved. So that now finishes up the lecture for today. I want you to go ahead for next week and look at your homework out of 1.5. And your homework packet will be included in this email. So your homework for next week is 1.5. You should be able to try them all. And if you have questions, we'll go over those next class period. But please do print out your homework and begin looking at it. We're not going to have enough time to cover this section again in detail. So you've got to watch the video and work through some of that homework.